Hello again, everyone. So this second talk of mine builds on what I discussed this morning, but as Johan already mentioned, with a stronger focus on Europe and a specific focus on gas. So let's kick this off quickly. What you see here is a picture similar to the one I showed you this morning. This is the CO2 emissions trend in the European Union in our new policy scenario. The good news here is it declines by over 40% over the next 25 years. And this scenario includes the nationally determined contributions, and it's designed to meet the targets of the EU's 2030 framework for climate and energy. Much of the heavy lifting in getting the CO2 emissions down in this scenario come from coal to gas switching and from greater deployment of renewables. But to achieve even deeper cuts in CO2 emissions, a wide range of different measures are needed. So here, this is showing what you need to do additionally to move from the CO2 emissions trend in the new policy scenario to the one in the sustainable development scenario. And you can see that efficiency and renewables feature quite prominently here. Now, what does this mean for natural gas in Europe? It means that in the new policy scenario, natural gas demand remains more or less flat on today's levels in the long term, even though you can see some interesting sectoral nuances. However, if we move to the sustainable development scenario, we see a decline in Europe's gas demand by around a quarter. And nevertheless, gas demand remains quite significant in the EU, even in 2040 in this scenario. You can also see from this slide that the brunt of the climate policy uncertainty lies in the power sector here. And that's something I'll discuss later in a little bit more detail. But now, first, let's have a look at what's happening in the household sector, in the heating sector. And you can see here that the gas demand declines, and these declines are driven by efficiency improvements. They're also caused by uptake of renewables, solar thermal, for example, or geothermal. But after all, household or buildings' gas demand remains quite resilient to climate policy. Why is this? That's due to two important constraints that we see. The first one has to do with the cost of efficiency improvements. The building stock in the European Union is quite old. That means that there is a lot of low-hanging fruit to be reaped, but it also means that once you want to do very deep efficiency measures, you need to start changing the building shell, and that makes it very expensive. So that's an important constraint to how much you can reach with efficiency in a cost-effective way. And the next one is the limits to electrification. Obviously, a nice scenario would be where you have a lot of renewable electricity, and then you use this renewable electricity to heat your houses with electric heating. Here, the problem is that in such a system, typically, most of the renewable electricity would be available in the summer, but the time when you need the electricity to run your heating would be in the winter. And here, the lack of cost-effective seasonal storage is a very important constraint for electrification in the household sector. Now, I'd like to discuss a little bit what's happening in industry. But to understand what is happening in industry, we need to first understand which branches in industry consume gas and how much. Around half of the EU's industrial gas consumption is in heavy industries, especially in the chemical industries. And these industries typically use gas either as a feedstock or to produce high-temperature heat. Now, there are certain things you can do in terms of efficiency improvements for high-temperature heat, but then, really, in the long term, there aren't that many substitutes to high-temperature heat from fossil fuels. However, the other half of industrial gas consumption comes from light industries. These are branches like manufacturing, food and beverages, textiles, for example. And these branches typically use gas to produce low temperature heat. And here there are actually a number of possibly or potentially viable alternatives. What you see here is a comparison between heat pumps and gas boilers in the new policy scenario. And you can see here that gas boilers remain a more cost-effective option in this scenario. However, if we move on to the sustainable development scenario, you can see that the economic calculation is tilted in favor of the heat pumps here. And that has to do with a strong signal coming from carbon pricing and an extension of carbon pricing to the light industry sectors as well. Obviously, this is a generic picture, and there are many different industry branches, many different countries in Europe. But I think the point I want to make here is giving you a feeling for why high-temperature heat provision by gas is relatively resilient, and most of the declines in industrial gas demand are actually happening in the light industries. If we now move on to the power sector, here you see the power generation fleet in the European Union evolving over time in the sustainable development scenario. And here a couple of expected things are happening. You can see a strong expansion in renewables. You can also see a strong decline in coal-fired and oil-fired capacities. And the thing I want to highlight here is that gas capacity actually remains constant over time at around current levels of 220 gigawatts. However, the role of this gas fleet is changing quite substantially over time. This line here represents load factors of the gas fleet. And you can see that in the period to the mid-2020s, the utilization of the gas fleet increases. It increases because gas plants are used to displace coal-fired plants. But then it starts to drop quite steeply. And that is the transition of the gas fleet away from fuel switching towards providing flexibility for the integration of variable renewables. So here, in this scenario, gas plants are absolutely critical for flexibility provision. Now, let's take another step. What does this mean for natural gas infrastructure in Europe? Obviously, it means that if you use less gas in a sustainable development scenario, you also transport less gas on average through the transmission and distribution networks. So the average daily shipments via the grid are declining the same way as annual demand declines, around a quarter. However, from a gas infrastructure perspective, it's much more important to know what's happening on the day of the highest gas demand. And that day will typically be a winter workday where businesses and factories are running, they're pursuing their economic activities, households are using gas to heat their apartments. There would be very little in-feed from PV. And if it's a windless day or a windless week, then all of these gas plants that you've seen on the previous slide are running hard to provide flexibility and balancing power. So if we add all of this up, we can see that actually peak gas demand declines by much less than average gas demand. So the gas network has a strategic value in ensuring the reliability of both gas supply and electricity supply. And now let's take the next step. What does that mean for network investments? It actually means that the size and the dimension of the network are relatively similar to what we have today, and also relatively similar to what we would see in the new policy scenario. And that means there are still very significant investment needs in the natural gas infrastructure for maintenance and repairs. And so on. And with this, I finished my second talk. I'm running quickly through the European outlook. Thank you very much.